Why are the studies of brain lesion patients important? Case studies of the brain lesion patients are extremely important in consciousness research for several reasons, in short. And the reason is, first of all, it provides us a phenomenological advantage compared to other different kind of methods. For example, if the adult patients still remaining, retaining the verbal communication ability, they can report us what it's like to be, in the brain damage state. And that's a very important kind of advantage for the case studies. And this is very different from, learning consciousness in the babies or animals or, even plants. None of them can tell you, their experience, right? So it remains initially, at least, we can't really study their consciousness through the rich, verbal description of what it's like to be there. And the second advantage is that we ourselves can become like them potentially. So if you have their own theory of consciousness, hopefully, you remain healthy, but at some point in your life, you can get involved in some kind of accident, and then you may lose some part of the brain. And then you can, test the prediction of the, theory about your conscious experience. If you lose it, then you can't. But if you retain it, then you can claim still that you still retain consciousness without this particular part of the brain. And so, what it's like question is, in principle, not possible to directly address, but it's possible to test it in such a rare case. And then there are critical experimental data also provided by this situation. Importantly, the brain lesion and also consciousness, either loss or no loss, comes together in this situation and at the same time. And that's very different from indirect evidence from, let's say, neuroimaging or neural recording in the monkeys and so on. Usually the link is not tightly, presented in this, case studies situation. So we can assess relationship between the brain and the consciousness much more effectively, sometimes very causally oriented manner. And so, as I said, which specific brain lesions cause what type of consciousness change or no change? That's a very important question. And then finally, it gives us a theoretical constraints on the link between the brain and the consciousness. So these data serve as the gold standard for any theory of consciousness has to satisfy, in a sense. How can we coherently explain all phenomenological and brain data? That's the question. Let's look at a little bit of the example here. So here is a hopefully familiar kind of example for you. This is a computer tomographic rendering of the famous Phineas Gage, whose brain was sort of penetrated by this rod from the bottom to the top because of the explosion in the construction section, And then, as you see, the part of the brain, especially the frontal part, gets completely damaged on one side, but he was able to live afterwards for a long time. And he was able to communicate and also behave, and everybody else around him can evaluate his personality and so on. And that's the sort of the story around Phineas Gage. And so the important thing here is that all these brain lesion patients can report their experience verbally. Next, so this is a picture of the locked-in syndrome patient. And here, if you sustain some kind of lesion around this part of the brain called brainstem, upper part of the brainstem, here. Then all the input information from the body doesn't come, and also somewhere around here is a motor cortex, but it also can't give motor command through brainstem. So what it ends up is that like this patient, she can actually move the eyes, blink is usually possible for both eyes, but not anything else. So that's called the locked-in syndrome patient. And this can happen when you get involved in the traffic accidents, for example. All right, and then another important issue is that for example, cerebellum can be lost when you are born, and but most of the people probably in the classroom still has it, but some people is actually living like this situation, and then we can ask the question, for example, is the cerebellum, this part of the brain really required, or how does it actually affect on the consciousness? And then also same thing like Phineas Gage, but even more devastating case is that not only the right part of the frontal brain, but it also goes to the left and right, both sides of the prefrontal cortex. And then in that case, we can ask the question of whether what is the role of the prefrontal cortex for consciousness more directly. Okay. And then eventually, what we want to arrive is that these data, both phenomenology and the brain, would constrain the theory of consciousness. And here is slides that is not easy to see for you, so you don't need to read the detailed contents here. But the left side is one particular class of the theory called the global neural workspace theory. And then the right side is another theory called the integrated information theory, which we will go more into the detail in week 10 to 12. And then both of the theory makes a different kind of question, prediction about the role of the parietal or frontal areas. So for example, GNWT says that when you see face, then there's some kind of face-related signal propagating through the brain, and then it reaches to the critical part of the brain, frontal parietal areas. And then that allows you to say, oh yes, I saw face. But if it's too weak or too faint, then it dies around here. And so prefrontal cortex cannot say that, oh, I saw face, and then that results in no face report. On the other hand, IIT says that there is some kind of a complex causal relationship, and that forms some kind of state, and that is already sufficient for to support conscious experience. And then without the involvement of the prefrontal areas like here, it already shapes and also generates or corresponds to experience of seeing this particular thing or this, and that naturally goes to be reported as a face or non-face. And that this kind of two theories are just examples, but if we have a better understanding of what happens in what particular type of the brain lesions on both brain and also consciousness, then many theories can be tested against each other. All right. So in sum, in this video, I explained that the brain-lesioned patients provide critical data to think about what consciousness is and is not and can be. And they provide a set of phenomenologically linked brain and phenomenology linked data that any theory of consciousness needs to explain. And also, these data together sets a stage that needs to be explained. That's consciousness and its physical basis. So doing this, you already noticed that the initial question of what's the relationship between the mind and the body becomes much more precise kind of form, which is that the consciousness and brain. That's the relationship that we want to understand. And the particular parts of the brain, if that relates to particular aspects of consciousness, it becomes like more qualia and specific part of the brain type of relationship. But that's later type of the discussion. Okay. So let's look at some of these examples in a bit more in detail.